let's begin this journey on reducing radicals. Now, I must tell you that when we reduce radicals, it's so important that we have the perfect square family, right? So, for example, the square root of 1 is, that's great because it's 1. Square root of 4 is 2 because 2 times 2 is 4. Square root of 9 is 3 because 3 times 3 is 9. And square root of 16 is 4 because 4 times 4 is 16, right? And so on and so on. So, it's super important to have our square root family because we want these, right? When we go to reduce radicals, we always want to reduce them with a perfect square in it. So let's go ahead and look at our first example here, right? The square root of 45, right? So one thing I didn't mention that we are going to need, and maybe I'll write it here, is this conjecture right here, right? It's a times b is equal to the square root of a times the square root of b, right? This is one that we went over in class together. And we're going to need this conjecture to be able to solve these problems. So if I go to my calculator right now and I try doing the square root of 45, right, I'm going to get a decimal answer, right? Whereas if I do something like the square root of 16, I get a whole number, right? Because 4 times 4 is 16. Well, the square root of 45, it's not a perfect whole number, right? It's going to give us a decimal answer. So we don't want a decimal answer. We want to be able to reduce this to a simplest form, right? And so in order to do that, well, we're going to end up getting the square root, right? And we're going to break it up. We're going to try to think about two numbers, right? Two numbers that multiply to give me 45. But we want one of these numbers to be a perfect square. Okay, we want one of those numbers to be a perfect square. So, since we have our little chart here, I always just start from the bottom and go down and start dividing by perfect squares, right? And not just some random numbers. So, we have this here. I'll go ahead and do 45 divided by 4, because 4 is the first perfect number, one of the first perfect numbers, right? Okay, I get 11.25, so that's not going to work. So then I go to 9, right? 45 divided by 9, which is the next perfect square. Oh, well now look at that. 9 times 5 gives me 45, but 9 is a perfect square. So we're going to get 9 times 5. Now we can break this up as the square root of 9 times the square root of 5 using this conjecture here, right? The a here is the 9, the b is the 5, and then we just break it up as the square root of a times the square root of b, right? So that's what we did here. Well, now that we did this, well, what is the square root of 9? Well, that's just 3, and then we just have the square root of 5. Okay? And this is our simplest radical, and we were able to reduce this down to a simplest form, right? So now we go back to 72 here. Again, the principle is still the same. What two numbers multiply to give me 72, but one of them is a perfect square, right? We want one of these to be a perfect square, like 4, 9, 16, etc. So I'll just go ahead and grab my calculator, and I always start at the bottom. 72 divided by 4, and that gives me 18, right? So this is good, because I know the square root of 4 is 2, but I'm going to get a perfect square, so I'll just write that down. Okay, we know 4 times 18 gives me 72, right? Now, the reason why I'm not going to go ahead and put it under here is because I want to keep going. I want to see if there's a bigger perfect square, right? The bigger the perfect square, the better. Because I'm thinking that 18 can probably be reduced even further. So I'm just going to keep going. 74 divided by 9. Would you look at that? And 9 and 8. 9 is a perfect square. So you could see 9 times 8 also gives me 72. Right? Well, think about it, right? If I was to do the square root of 9, I'd get 3, and then the square root of 8, we can still reduce the square root of 8 even further, right? So again, I just want to keep going down until I can see if I can find an even better perfect square. So I'll divide it by 16. Okay, 16 is not going to work. 72 divided by 25. That's not going to work either. I just like to just keep going down real quick, and I just want to be patient, right? There's nothing wrong with having oh, see, look at that. Now we have another one, 36 times 2. And that's perfect, because 36 times 2. And the reason why I prefer that one over all these ones right here is because this 2 is already like 2 is a small number, right? I can't reduce 2 any further. I can reduce the 18 further. I can reduce the 8 further. But I can't reduce the 2 any further. And that's why I wanted that one, right? So sometimes I like to just go through a few. So now we break it up using our conjecture, and we're going to get the square root of 36 times the square root of 2. Well, the square root of 36 is just 6 times the square root of 2. And that's my final answer, okay? Now, if you don't believe me, right? If you're sitting here saying, I don't know what you're talking about with, what I don't know anything of what you were talking about with, oops, I don't want to erase these here, with the 4 and the 18 and whatnot, and the 9 and the 8. Well, let me go ahead and show you, all right, how you're still going to get the same answer, but you're going to have to do way more work. So let me go ahead. I'm just erasing these right here. And as I erase these ones right here, all right, erase, 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 great. I will do it. Let's go ahead and try it out. So let's do the square root, oops, of 9 times 8, right? And we're going to get the square root of 9 times the square root of 8, which is going to give me 3 times the square root of 8. All right. Now, what I mean is that I have to reduce down 8 even further, right? I have to reduce the 8 even further. So if I go to reduce the 8 even further, well, we're going to get 3, oops, I forgot to make these smaller, right? Square root, well, 4 times 2. And then we're going to get 3 square root of 4 times the square root of 2, which is going to equal, what's the square root of 4? 2. So we're going to get 3 times 2 square root of 2, which is going to equal, well, what's 3 times 2? We're going to get 6 square root of 2. Okay, so you can see we still get the same answer, right? But you can see that it required more significant work. We had to go a lot of steps just to get our final answer. Where here, if I just kept going, I got a perfect number, perfect number, perfect square number, right? 36, but 2 is really reduced down, so we're good, right? Now here's a few more that you can try out on your own. And like I said, I recommend before choosing the first perfect square. So if you do 243 and you divide it by 4, okay, that doesn't work, and we keep going. We divide it by 9. Okay, so that one's going to work, and I'll just maybe write it on the corner, 27, right? But I want to keep going. I want to see if there is a perfect square that's better than that. Or I shouldn't say better, but I should say something that's bigger, right? So I'm just going to keep going because I'm getting these decimals. 16, 25 is next. You can always refer to the cheat sheet I wrote up above. 36. That doesn't work. So it looks like we may be running out of luck here, right? Maybe initially we're thinking, oh, no, this isn't going to work. All right, but I like to just go all the way up to 10, right? That's why I wrote first 10. So divide by 64. That doesn't work. And then I'll keep going, right? The next one, 64 is 81. And then, okay, now see, if I was just being patient, I got a really big perfect square number, right? 81. And 3, well, 3 is already pretty small, so it's already in its simplest form. We can't reduce the square root of 3. So if we go to rewrite this, we're going to get the square root of 81 times 3. Now all we do is just break it up. The square root of 81 times the square root of 3. And the square root of 81 is 9 times the square root of 3. And that's my final answer, right? And if you don't believe me, what we could always do is go to the square root of 243, right? And I'll show you. You get 15.588. Well, now let's do 9 times the square root of 3. And we should get the exact same answer, which we do. All right, perfect. All right, go ahead and you try doing this problem over here.